9.5, we're going to be looking at some solving of trigonometric equations. And so just want to kind of start with a review of some concepts and thoughts before we kind of get into the grid of it. So number one here, we're going to be looking at solving linear trigonometric equations using sine and cosine. And so a couple things I want to review with you, just remembering some of the things about sine and cosine. I'm going to review that. Remember that sine and cosine are both periodic and have a period of 2 pi. We're going to use this quite frequently as we work through some examples. So that means that every 2 pi, the y values are going to repeat. So it's going to be very important for us to emphasize domain and realize what quadrant we're in, and also understand how many solutions we might have for something. So when we're solving equations with these trig functions, you should consider this right here, that sine theta is equal to sine of theta plus or minus 2k pi, where k is any integer, and this just helps us to find other angles within whatever kind of domain that we're working with. So as we're solving some trig equations, some things to remember. We are going to be using some of the same techniques as solving algebraic equations. So we're kind of taking a break from proving identities and getting our left to look like our right. And we're going to be solving some things out. So remember that you read equations left to right. You want to look for patterns, factor, find common denominators, substitute for a variable to make, a very straightforward approach. And look for any trig identities from the previous sections that could be beneficial for you as you work through this. So kind of a how-to here. If we're given a trig equation, we're going to solve using algebra. Look for a pattern, substitute, solve, substitute, solve. So just kind of give us a little step-by-step. So if you ever get stuck, go back to your how-to and start with step 1. So let's start here and let's look at finding some possible exact solutions for this equation here. So we need to make sure that we remember what we're working with, and we remember our unit circle as we go through some of this. So if you remember from your unit circle, looking at it and finding where does cosine theta equal to 1/2, so you definitely want to have your unit circle completely filled in one handy as we work through this section. According to the unit circle, that would be where theta is equal to pi over 3 and 5 pi over 3. And we are just looking within the domain from 0 to 2 pi, so we want to keep that in mind. So if I want to find all possible exact solutions, here's the two that are within this domain of 0 to 2 pi. They don't restrain me any within that first period, and so we need to write it in a more general sense. So we'll say that theta is equal to pi over 3 plus or minus 2k pi, so that we can kind of rotate around that through the different periods. Then we can also say 5 pi over 3 plus or minus 2k pi, and again that's just going to cycle through, and this is all where k is an integer. And so all possible exact solutions for this equation. We used our unit circle to get the two within the first period, and then we were able to write it in a more general sense for any other periods that we go through. So let's look at one with sine. And so it says find all possible exact solutions for the equation sine t equal to 1/2. 1/2 is a nice one from your unit circle. And so I could say t is equal to pi over 6. And again, handy dandy unit circle here, t is equal to 5 pi over 6. But again, I want all possible exact solutions. They don't talk anything about domain in this one. And so I'm going to say plus or minus 2k pi, plus or minus 2k pi. And again, this is where k is an integer. And it goes back to our conversations at the beginning of this section dealing with sine and cosine and talking about how their periods are within 2 pi. Let's look at this last example here before kind of moving forward. We're going to solve the equation exactly. We're given 2 cosine theta minus 3 equal to -5, and do note that we are just looking at between 0 and 2 pi with this one. So just like I would with any algebraic function, I'm going to solve for the variable. In this case, we're looking for the angle that is all equal to this. And so I'm just going to slowly move things around. So I'm going to add 3 to the other side. And so I get 2 cosine theta equal to negative 5 plus 3, so negative 2. I'm going to divide both sides by 2, and this gives me cosine theta equal to negative 1. Now, the good news is negative 1 is a cosine value within my unit circle. And so I would just say that theta is equal to pi. You'll notice I'm not talking about k pi or 2k pi at this point because, again, we have a domain restriction of theta being between 0 and 2 pi or being in that first period of cosine. And so you can see that just with this small problem here, all my basics from algebra apply. Whatever I do to one side, I must do to the other. I'm going to move my operands over one at a time. So I'm going to deal with the negative 3, then the 2, and then I'm going to deal with my cosine theta. So just to kind of give us a basis here and kind of review, even give you something nice here in your notes. Number 2, solving equations using a single trig function like the one you solve above. You want to first make sure to use all your algebraic techniques and your unit circle. We're going to see some more algebraic techniques as we move forward, but let's just go ahead and review your unit circle for a minute. Make sure you remember your unit circle. This has not only our radians and our degrees, but each of these ordered pairs, x, comma, y, deals with your cosine and your sine. And when we have our cosine and our sine, these are like our very basic building blocks as we are moving forward. And so if we have a unit circle, we have any angle on this unit circle, we can tell you cosine or sine, and then I can also tell you tangent or cosecant or secant or cotangent based off just this knowledge. So this just gives us a really nice unit circle here within our notes. So let's look at here, part C, and let's do some examples and kind of see how this pans out for us. So I'm going to start working here, and I'm going to say, you know what, let me just start isolating this trig function because my goal is to get this theta completely by itself. I am going to remember that I am within the domain between 0 and 2 pi. So I get 2 sine squared theta equal to 1. Divide both sides by 2. So sine squared theta is equal to 1/2. I'm going to square root this to give me sine theta is equal to plus or minus the square root of 1/2, or plus or minus 1 square roots of 2. Still not loving that, so let me rationalize that out. So I actually get the square root of 2 over 2, which is very helpful because if I go back again to my unit circle, even just on the previous page, I can see that this occurs. Where does sine theta occur and give me positive and negative square root of 2 over 2? That happens at pi over 4, 3 pi over 4, 5 pi over 4, and 7 pi over 4. Again, we are restricted within that first period at period between 0 and 2 pi. So I do want to make sure that I have all 4 answers that I need, and I want to make sure that I have all of them and not to exceed the 2 pi. So let's go down here to this next one. It says solve the following equation exactly. Gives me cosecant theta equal to negative 2. And now it has a restriction between 0 and 4 pi. So just kind of keep that in mind as you go. And I say this a lot, but you kind of always want to go back to your basic building blocks if you're not sure what to do. So my first thought with this is, you know what, let me just rewrite this as 1 over sine theta equal to negative 2. Because I think that'll help me out here better than working with cosecant, especially because you can see we've been using our unit circle the whole way. So if I flip both sides of this, I would actually end up with sine theta equal to negative 1/2, just using the reciprocal for both. Which also benefits me because then go to my handy dandy unit circle. And where is sine theta equal to negative 1/2? So that means I'm looking for the y value on my unit circle of my ordered pairs. Where is it? Negative 1/2. And this would be at 7 pi over 6, 11 pi over 6. I am between 0 and 4 pi, so I'm going to loop again, and this will give me 19 pi over 6. And 23 pi over 6. So I want to make sure that I am aware of the rest of the problem or the instructions. And I can't say it enough. I tell all my students, read the instructions, read the instructions. If they gave you 0 and 4 pi, it was for a reason. If you don't use that, you might check on what you're doing and make sure you fully answered it completely. Last example here, solve the equation exactly, and they gave me tangent theta minus pi over 2 equal to 1. And again, the domain for theta is going to be between 0 and 2 pi. Now, do remember that tangent was a little bit different than sine and cosine. Its period is actually just pi. Remember, it had the asymptotes at the negative pi half and pi halves. And so I'm just going to think about what I know first. When do I know that tangent of something gives me a 1? I know that tangent of pi over 4 gives me 1. So what I'm going to do is I'm going to take this pi over 4 and set it equal to the inside over here. This gives me theta minus pi over 2 equal to pi over 4, which gives me theta equal to, just adding that over there to the other side, gives me 3 pi over 4. Now I am within the RAM of 0 and 2 pi, so what I'm going to do is I'm going to add the period of tangent being pi to the angle I already have, and that gives me 7 pi over 4, which is also in that domain. If I were to add another pi in there, that would give me larger than the 2 pi, and so I'm just going to stick with these answers here. So I've got theta being 3 pi over 4, and I've got 7 pi over 4. Moving forward. Example here, before we move on into 3, it says identify all exact solutions to the equation 2 tangent x plus 3 equal to 5 plus tangent x. And then they show us the domain here of our x. So I'm just going to kind of move slowly and do some of my algebra techniques here. So I'm going to distribute that 2 throughout to get rid of my parentheses. If you're unsure what to do, find a small step that you can complete and go from there. I'm going to go ahead and move my tangents together. So I'm going to say minus tangent x on both sides. This leaves me with tangent x plus 6 equal to 5 minus 6. So I get tangent x equal to negative 1. And again, I go back to my unit circle. And where does this happen? This happens where x is equal to 3 pi over 4. And when x is equal to 7 pi over 4. So again, using that period of tangent being pi, I get my 2 answers for this. So just be careful if you move through these. Make sure you're aware of your domain. Did you get all the solutions throughout there, or do you need to add in the period to find any missing solutions? Now, all of these have been done with your unit circle, and maybe you can't do all of them with your unit circle. Maybe you can't figure out the tangent of the angle because it's a value that's not on there, and that's what's going to lead us into part 3 here.